Hello students. Now today, in continuation of catalysis, we have to discuss about the concept of heterogeneous catalysis. When you talk about heterogeneous, hetero means different. Name tells itself, hetero means different. It means that we have to talk about such reactions where reactant and catalyst are in different phases. Catalysts and reactants are not in same phase. Let us take this example, like nitrogen we have taken, it is in gaseous form, hydrogen is in gaseous form, and iron, which is going to act as a catalyst, it is in solid form. So it is a good example of heterogeneous catalysis. And remember, in general, in heterogeneous catalysis, mostly catalyst is solid and reactants are generally gas. Sometimes, in some cases, reactants can be in liquid form as well. Just to share one example, you know it well, like suppose we have taken the hydrogenation of vegetable oil. Now here, this vegetable oil is in liquid state. You pass hydrogen, it is in gaseous phase, in presence of nickel, which is in solid state, and you get ghee, again solid. So what I mean to say, as I told you, catalyst in general in heterogeneous catalysis are solid, reactant mostly gases, but sometimes they can be liquid also. Like in this hydrogenation of vegetable oil, one of the reactant is in liquid form. Now, as we discussed about the mechanism of homogeneous catalysis, similarly, we have to talk about the mechanism of heterogeneous catalysis also, and to explain it, we have adsorption theory. Name tells adsorption means it will involve the surface of catalyst, not the bulk, because it is we are talking about adsorption. And as I told, mostly catalyst is solid. So what do we find? What are the important steps? This process completes in 5 steps. It is represented diagrammatically here also. You first see the very first step, according to adsorption theory, the reactant maximum gases, but it may be liquid also, whatsoever, it diffuses towards the surface of catalyst. This is diffusion of reactant towards the solid catalyst. For example, A and B are gases and they diffuses towards the surface of solid catalyst. Second step, adsorption of reactant gases on the catalyst. So this is the second step. On this solid surface, A and B reactant, they undergo the process of adsorption. And I want to tell you one thing, it is adsorption, but here it involves chemical adsorption. It is not physical adsorption. Means between reactant and solid, there is formation of chemical bonds. So this is, make sure it is an example of chemical adsorption. Now when adsorption is done, what is the advantage of this adsorption? Actually, if the reactant are gases, they are very far apart from each other. This catalyst bring these reactant to one surface and make the reaction fast. So this is the advantage of this adsorption. Reactant on surface, they get better chance to react. They form bonds. Now what? You just see reaction. Means reactant undergo reaction to form products. Products is formed on the catalyst surface and it is still present on the surface of catalyst. Now next step is there, which is called desorption. Desorption is inverse of adsorption. When you say desorption, it is inverse of adsorption. Means when product is formed, when bond between A and B is formed, then their bond with catalyst weakens, they break, and as a result, product undergo the process of desorption. This is the last step what I am telling you, this is desorption. And when desorption takes place, when products are formed, they undergo the process of diffusion. They diffuses out from the surface. So these are the 5 steps. Diffusion of gas, then gas undergoes adsorption, it get better chance to react, form product, product undergo the desorption, and it diffuses away from the catalyst surface. Simple, straight. This is adsorption theory of heterogeneous catalysis. Now when we are talking about heterogeneous catalysis, what I told, maximum cases solid is the catalyst. So there are certain important characteristics of solid catalyst as well. They exhibit certain important characteristics. What is it? The very first, activity. Activity means, remember, these are normally asked in questions in the short form in exams. So just take care, see it carefully. The very first property is activity. Activity means it is the capacity of a catalyst to increase the rate of reaction. Means a catalyst can increase the rate of reaction to what extent? Like you see, it is written here, a catalyst can increase the rate of reaction as high as 10 raised to the power 10 times. To a very large extent, a catalyst can increase the rate of reaction. So remember, if anybody asks what is activity, the capacity of a catalyst to increase the rate of reaction means to what extent a catalyst can increase the rate of reaction. Second is specificity. Now it's very clear. Specificity comes from term specific, means every substance cannot catalyze all the reactions. A particular substance is a catalyst for a specific reaction. Make sure. You see, here for nitrogen and hydrogen reaction, we are using iron as catalyst. You see, in this hydrogenation of vegetable oil, we are using nickel as a catalyst. It shows that yes, catalysts are highly specific in nature. And it's very clear reason. What I told, because during the adsorption phenomena in catalyst, chemical adsorption takes place of reactant on the solid surface. So since it is chemical adsorption, chemical bond is to form, so a particular reactant can form a bond with a particular catalyst only, which make or which prove the property of specificity. Next, very important, selectivity. Catalysts show a property of selectivity. Just see how interesting it is. I told for every different reaction we need different catalyst. Now selectivity is a different property. Here catalyst select the product, means we are using the same reactant, but when we are using different catalyst, we are getting different products. This is what you call, this is called selectivity. What is selected? Product. Who is selecting the product? Catalyst is selecting the product. With same reactant, different catalysts are giving different products. You see, reactants are CO, means carbon monoxide, and hydrogen in all these 3 cases. But here when we use copper, we got formaldehyde. When we use copper zinc oxide with chromium oxide, we got methanol. When we use nickel, we get methane. Means same reactant, different catalysts selecting different products. So these are 3 important characteristics of catalyst, and especially the solid catalyst. Now what next? Something more to know there. No doubt, catalyst is you can say increasing the rate of reaction. But my dear, there are certain substances which affect the catalyst. See, interesting. Catalysts affect the reaction, and there are certain substances which affect the catalyst. And these are 2 substances. One is called catalytic promoter, and another is called catalytic poison. Catalytic promoter means which increases the effect of catalyst. Means catalyst affecting a reaction, catalyst increasing the rate of reaction, but a catalytic promoter promote this catalyst to work better in a particular reaction. For example, this is Haber's process of formation of ammonia. Here iron is going to act as a catalyst. Now when you add molybdenum to it, This is molybdenum. You add molybdenum to it. Now here molybdenum is a promoter. It is a catalytic promoter. Now what it do? It enhances the activity of catalyst iron, so that iron can work better and it can increase the rate of reaction faster. This is catalytic promoter. Similarly, we have catalytic poison. Now, as I think it is clear, the name tells poison means it decreases the effect of catalyst. Like for example, in the same process, if you add H2S in place of molybdenum, it is written there. Now it is catalytic poison. What it do? Now it decreases the effect of iron. Now you can ask, okay, sir, how this H2S will decrease the effect of iron? So my dear, this H2S, actually on the iron surface, these reactants are to be absorbed, but this H2S absorbs itself, means block the sites where these reactants are to be absorbed. So automatically activity of catalyst is decreased by. So these are catalytic poisons. These are some important characteristics which I had to discuss. Now last, just to add to your knowledge, there is a concept of autocatalysis. See, you know, hydrolysis of ester it is, and this hydrolysis of ester gives acid and alcohol, and we know this process is catalyzed because of presence of H positive ion. It is catalyzed because of presence of H positive ion. Now let us consider, we have taken ester, we added water, but we forgot to add acid. It doesn't mean that reaction will not take place. Reaction will take place, but at a slower rate. But as and when ester is initially dissociated to form, this is carboxylic acid and this is alcohol. Now this carboxylic acid, because acid is formed, now it is going to catalyze the further reaction. This is called autocatalysis. Autocatalysis means product which is formed, it is going to catalyze the reaction. This is the concept of autocatalysis. And similarly, we have another concept, interesting, induced catalysis. See, what do we find in this induced catalyst? In this induced catalyst, for a reaction, we do not have any catalyst. Now see, two reactions takes place simultaneously, and one reaction catalyzes the another reaction. This is the concept of induced catalyst. Just for an example, sodium sulfite. I repeat, sodium sulfite undergoes oxidation to form sodium sulfate. Now this reaction catalyzes the oxidation of sodium arsenite. This is induced catalysis. Formation of sodium sulfate, or you can say oxidation of sodium sulfite influences the oxidation of sodium arsenite. Make it very clear. So this is all about this concept, right my dear? Thank you.